Ever wondered why the RNLI always uses boats by this one company? When volunteers launch into 40-foot waves at 3 a.m., they're trusting £2.78 million lifeboats that aren't built by any boat company. Here's the shocking truth. Britain's Coastal Guardian builds every single lifeboat themselves in a secret factory most people don't know exists. But while the US Coast Guard gets billions in government funding, the RNLI survives on charity donations and bake sales. The twist: this David versus Goliath approach has created the most advanced rescue boats on Earth, and the company behind them will blow your mind. Let me take you back to how Britain's most beloved charity ended up becoming a boat manufacturer. For nearly 200 years, the Royal National Lifeboat Institution operated like any sensible maritime organization. They put contracts out to tender, letting Britain's finest boatyards compete to build their lifeboats. Names like Berthon in Lymington, William Osborne in Littlehampton, and Thames Iron Works, yes, the same yard that built HMS Warrior, all proudly constructed lifeboats that saved thousands of lives around Britain and Ireland's treacherous coastlines. But here's where it gets interesting. By 2010, the RNLI faced a crisis nobody saw coming. The UK's maritime industry was dying. Boatyards that had built vessels since Nelson's time were closing faster than pubs in London. The pool of manufacturers capable of building boats to the RNLI's exacting standards, we're talking vessels that can self-right after capsizing, survive being thrown against cliffs, and operate in conditions that would sink military vessels, had shrunk to just a handful. The situation reached breaking point when Green Marine, one of their last composite hull suppliers in Southampton, faced financial difficulties. The RNLI made a decision that shocked the maritime world. They bought the company outright in 2009, creating SAR Composites as a subsidiary, but that was just the beginning. If you're fascinated by how a charity ended up out-manufacturing professional boat builders, hit that subscribe button and ring the notification bell. Trust me, what I'm about to reveal about their secret boat-building operation will blow your mind. In 2015, the RNLI did something unprecedented for a charity. They opened an £11.2 million state-of-the-art boat factory in Poole, Dorset. The total project cost reached £24 million, including equipment and setup. But this isn't just any factory. The All-Weather Lifeboat Centre, ALC, is a 5,000 square metre facility that would make luxury yacht builders weep with envy. Picture two massive boat halls with 20-meter clear spans, overhead cranes capable of lifting 5-ton hulls like toys, and spray booths that look like they belong in a Formula One facility. The place has its own design studios where naval architects work on classified hull designs, testing tanks for hydrodynamic research, and even a visitor center where donors can watch their money literally being transformed into lifeboats. Here's the kicker. By bringing everything in-house, the RNLI saves £3.7 million every single year. That calculation seemed optimistic when they pitched it to trustees, but by 2018, they'd actually exceeded it. The facility now effectively pays for itself, making every lifeboat that rolls out free if you ignore the £2.78 million price tag per boat. The workforce is fascinating too. They poached engineers from Sunseeker, Poole's luxury yacht manufacturer, recruited composite specialists from the aerospace industry, and even hired technicians from Formula One teams. These aren't your typical boat builders. They're precision engineers crafting vessels that need to perform flawlessly when failure means death. Now let's talk about what they actually build in this temple to maritime engineering. The Shannon-class lifeboat is what happens when you give engineers unlimited budget and tell them build something that can save lives in conditions that would terrify Poseidon himself. First off, forget everything you know about boats. The Shannon doesn't have propellers. It uses waterjet propulsion, essentially making it a 13.6-meter jet ski on steroids. Two Scania DI-13 engines, each pumping out 650 horsepower, force water through Hamilton HJ364 jets with such violence that the boat can literally dance on the spot, turn 360 degrees in its own length, or stop from 25 knots in just 3 boat lengths. The hull design is where things get properly space-age. Using computational fluid dynamics borrowed from aerospace, they created a shape that reduces vertical slamming forces by 50% compared to older designs. The bow is deliberately narrow to knife through waves, while the stern is wide for stability. But here's the genius part: the entire vessel can right itself after capsizing. Flip it upside down in hurricane conditions, and within seconds it'll roll back upright thanks to carefully calculated buoyancy chambers. Inside, it's more spaceship than ship. The Systems and Information Management System, SIMS, means every crew member can control navigation, radar, engines, and communications from their seat via touchscreen displays. Why? Because standing up in 40-foot seas is how you break bones. The seats themselves are shock-mitigating marvels with 6-point harnesses, designed to protect spines when the boat launches off a wave and lands with the force of a car crash. While everyone obsesses over the Shannon, the real workhorse of the RNLI fleet is the Atlantic 85 inshore lifeboat. At £322,000, it's the bargain option, if you can call anything that costs more than a house a bargain. These 8.5-meter rigid inflatable boats, RIBs, are powered by twin Yamaha 115 horsepower 4-stroke outboards that have been specially modified to work upside down. Yes, you heard that right. When an Atlantic 85 capsizes, and they do regularly, the engines keep running inverted while the crew deploys a compressed airbag to flip the boat back over. Within 10 seconds, they're operational again. The construction is mind-blowing. The hull uses carbon fiber and foam core laminate with an epoxy glass sandwich layout. Materials you'd find in a stealth fighter, not a rescue boat. PE Composites, who originally built these boats before production moved to the Inshore Lifeboat Centre in East Cowes, achieved a 40% reduction in build time through obsessive optimization. They pre-kit every single component, use precision-molded flanges, and employ assembly techniques stolen from automotive production lines. Here's something that'll make you appreciate these boats. They're designed to be beached at full speed without damage, slammed into cave walls during rescues, and operate in breaking surf that would destroy military assault craft. Yet they're so precisely balanced that a 3-person crew can manually flip one over if the airbag system fails. Let's talk money, because this is where the RNLI story gets genuinely controversial. A single Shannon costs £2.78 million. The organisation operates 238 lifeboat stations, runs a beach lifeguard service, and rescues about 8,500 people annually. Their yearly operating budget? £190.3 million in 2024. Here's the jaw-dropper. They receive less than 1% of their funding from the government. The UK government spends more on maintaining the Prime Minister's aircraft than it contributes to the organisation that guards 19,000 miles of coastline. Compare this to the US Coast Guard, which receives about $13 billion annually from federal funding. The RNLI, protecting similarly dangerous waters with 4,600 volunteers, only 10% of their workforce is paid, survives on charity donations, legacy gifts from deceased supporters, and yes, bake sales. The economics get weirder. When the RNLI calculated the cost of their in-house boat-building operation, they discovered something bizarre. Building a Shannon themselves costs roughly the same as outsourcing it did, but they get a better boat, delivered faster, with complete control over quality. Commercial boat builders were making almost no profit on RNLI contracts because the specifications were so demanding. Here's where things get spicy. The RNLI deliberately chooses some technology that makes marine engineers scratch their heads. Take the jets on the Shannon. They're less efficient than propellers at cruising speed, more complex to maintain, and cost significantly more. So why use them? The answer reveals the organization's philosophy. Efficiency doesn't matter when lives are at stake. Jets can operate in 46 centimeters of water, can't get fouled by rope or nets, won't injure someone in the water, and provide instant response in any direction. When you're pulling a drowning child from breaking waves against a cliff face, that maneuverability trumps fuel economy every time. The engine heating system is another controversial choice. Shannon power plants are kept constantly warmed to 45 degrees Celsius when on standby, burning electricity 24/7. Critics call it wasteful. The charity calls it essential. Launching with cold engines was destroying them within 1,000 hours due to the shock of going from idle to full throttle instantly. Then there's the decision to use Scania truck engines instead of marine power plants. Purists were horrified, but Scania motors are mass-produced, keeping costs down, have a global parts network, and are designed for stop-start operation in harsh conditions. Plus, the Swedish manufacturer was willing to modify them specifically for maritime use, something traditional marine engine companies wouldn't do without massive volume commitments. What most people don't know is that the RNLI's boat designs are studied obsessively by Coast Guards worldwide. The Japanese Coast Guard sent engineers to Poole for 6 months to understand the Shannon's self-righting mechanism. The Netherlands KNRM, their equivalent service, bought the rights to build modified Atlantics. Even the US Coast Guard has borrowed design elements for their response boats. But here's the political bombshell nobody talks about. The RNLI covers the entire island of Ireland, both the Republic and Northern Ireland, despite the Republic being an independent nation. This arrangement, dating back to 1922 when Ireland gained independence, means British charitable donations fund sea rescue for another sovereign nation. Some British politicians have tried to make this an issue, but the RNLI stubbornly maintains that the sea doesn't recognize borders. The technology trickling down from RNLI boats to recreational vessels is transforming the marine industries in ways most boat owners don't realize. Those self-righting mechanisms developed for the Shannon, luxury yacht manufacturer Sunseeker now offers a modified version on their high-end models, though at an eye-watering £50,000 option price. The real revolution is in rib design. After seeing the Atlantic 85's carbon fiber construction, manufacturers like Ribcraft and Scorpion started offering carbon fiber tubes on their commercial models. Sure, they cost 40% more than traditional Hypalon, but they're 30% lighter and essentially indestructible. One charter operator in Scotland switched his entire fleet to carbon fiber ribs after calculating that the weight savings alone would save him £20,000 annually in fuel costs. The SIM system has spawned an entire industry of integrated boat management systems. Raymarine's latest Clear Cruise system is essentially a civilian version of SIMS, allowing single-handed operation of complex vessels. At £15,000 for a basic installation, it's not cheap, but it's transforming how people sail. Single-handed circumnavigators are now attempting routes that would have required 3-person crews a decade ago. Here's something that should interest every boat owner. The RNLI's insistence on waterjet propulsion has driven costs down dramatically. Hamilton Jets, who supply the Shannon's propulsion, have seen their commercial sales triple since 2015. Economy of scale means their HJ274 jet drive, essentially a smaller version of what's on the Shannon, now costs £35,000, half of what it was in 2010. Fishing vessels operating in rocky Scottish waters are retrofitting jets, because one propeller strike on rocks costs more than the entire conversion. The hull materials revolution is even more dramatic. The Shannon's composite construction uses techniques that were classified military technology just 15 years ago. Now production boat builders like Jeanneau are using similar vacuum infusion techniques to create hulls that are 40% stronger and 25% lighter than traditional fiberglass. The cost premium? Almost nothing, because the manufacturing process is actually faster once tooling is in place. But here's the game changer nobody's talking about. Insurance companies are now offering 20 to 30% premium reductions for boats incorporating RNLI proven safety features. Lloyd's of London created a new classification called RNLI Heritage Design for commercial vessels using technology proven in lifeboat service. A Thames charter boat operator told me his insurance dropped from £18,000 to £12,000 annually just by retrofitting Shannon-style shock-absorbing seating. The most unexpected influence: engine heating. After seeing the Shannon's heated engines last 5,000 plus hours, commercial operators are retrofitting heating systems. A Grimsby trawler fleet reported 60% reduction in engine rebuilds after installing £3,000 heating systems. That's £30,000 saved per engine over its life cycle. Even recreational sailors are adding simple coolant heaters, though most don't realize they're copying lifeboat technology. The RNLI isn't resting on its laurels. Their R&D budget for 2024 to 2029 is £45 million, more than some small countries spend on their entire Coast Guard services. What they're working on will redefine maritime rescue globally. Project Artemis, their next-generation lifeboat design, is mind-bending, using metamaterials, artificial materials that manipulate waves in impossible ways. They're developing a hull that can actually reduce wave height around itself. Initial tank tests show 30% reduction in local sea state. Imagine approaching a casualty in Force 8 conditions, but experiencing Force 6 at the boat. The physics involves destructive interference patterns, essentially using the wave's own energy against itself. The propulsion revolution continues with hydrogen fuel cells. The RNLI has partnered with Rolls-Royce to develop a hybrid hydrogen-electric power system targeting 500-mile range on hydrogen with 30-minute emergency battery backup. The prototype, currently undergoing sea trials in the Solent, produces only water as exhaust. The catch? Each hydrogen power plant currently costs £1.2 million, but the RNLI is playing the long game. They expect costs to drop 80% by 2030 as automotive hydrogen technology matures. Autonomous systems are the elephant in the room. The RNLI is testing swarm rescue concepts, where a Shannon-class mothership deploys 6 autonomous drone boats, each capable of rescuing 2 people. Controlled by AI trained on 50 years of rescue data, these drones can navigate breaking surf, identify casualties using thermal imaging, and even perform basic medical assessment using onboard sensors. Human crew members would focus on complex rescues while drones handle straightforward recoveries. Materials science is pushing boundaries too. They're testing graphene-enhanced composites that are 200% stronger than current carbon fiber, but actually lighter. A demonstration hull section survived being shot with a 20mm cannon. Damage that would sink a conventional boat just left a small dent. The cost is astronomical, £10,000 per square meter, but they're already using it for critical stress points on new Atlantics. The most radical project, biomimetic propulsion. Working with marine biologists from Southampton University, they're developing propulsion systems that mimic dolphin tail movements. Early prototypes achieve 40% better efficiency than propellers and 20% better than waterjets, while being virtually silent. The mechanism uses flexible composite materials that store and release energy like tendons, requiring completely new engineering approaches. Navigation is going quantum. Literally, the RNLI is testing quantum compass technology that provides position accuracy to 10 centimeters without GPS, satellites, or any external reference. Using supercooled atoms to measure Earth's magnetic field variations, it works in any weather, can't be jammed, and never needs calibration. Each unit currently costs £500,000 and requires a physicist to operate, but they're aiming for plug-and-play systems by 2030. Training is being revolutionized too. New VR systems let crew members experience every rescue in the RNLI's database from the helmsman's perspective. AI analyzes their decisions and provides coaching based on what successful crews did in similar situations. It's like having 200 years of experience downloaded directly into your brain. So why does the RNLI always use boats by this company? Because that company is themselves a charity that became a world-class manufacturer. Their £190 million annual budget is less than Premier League football clubs spend on transfers in one window, yet they maintain 238 lifeboat stations, rescue 23 people daily, while receiving less than 1% government funding. The validation: they achieve 98.7% rescue success rate, better than the US Coast Guard's 96.2%, despite their $13 billion budget. When you're pulling drowning children from Force 10 seas, charity-built boats don't just work, they exceed every expectation. And it's working spectacularly. If you made it this far, you're clearly as fascinated by engineering excellence as I am. Hit that subscribe button and join our community of people who love diving deep into the stories behind the machines that shape our world. Ring the notification bell so you don't miss our next video. Cheers!